Hello guys, welcome to Solving Solutions, your number one channel where you get solutions to all your solving problems. It's nice having you in class again today. How have you been? We are going to continue on our last video. We have been showing you we have been giving you some solution on matrices. We started by using the basics and then we went on to use calculator, and then we have used the matrix to solve a problem on adjustment computation. Now on this video, we are going to show you how you can use simple Excel commands or Excel functions or simple Excel formula to solve that particular problem we solved the other day on our last video. Now the essence of showing you this is that perhaps you have something like an assignment, or maybe you are learning on your own and you have done it manually, you want to confirm your answer. And again, the application of Excel is actually limitless. So learning this little formula, or maybe this little formula, set of formula, and then applying them to other set of questions, or maybe any other problem you have on adjustment computation or any other course. If you have any issue related to this, maybe an assignment, quiz, or anything you would want us to help you fix, you can always contact us and we will be very glad or willing to assist you on it. Now, you remember what we were trying to do that day was that on the last video, we were trying to get the adjusted value of a length AD, right? Good. And then they gave us the length AB, BC, CD, AC, and BD. Now, these were the observed distances they gave to us, and then we were able to write out the equations for each of the corrected, the corrected parameter. Now, after doing that, we now formed the matrices of either the matrix of let's say the A matrix, which is the coefficient of unknown. We form the L matrix, which is the coefficient of the computed values minus the observed values, and then we use this formula to carry out our computation. Now on this video, we are going to show you how to apply this formula using this Excel spreadsheet. Now the first thing is that you can always go back to that video where you would see how we came about these values on this matrix A, and how we came about these other values on this matrix L. Now the first thing on this formula is that we have A transpose, right? Which means we are going to transpose this A matrix. Now you would have to pay attention. The essence of not deleting whatever we have here is not because we cannot get them back again, but we left it here so that it can actually guide us, or maybe we can use that to control ourselves. Now the first thing now is that when you want to transpose a matrix, as we have now, you know that these are the rows, right? And then these are the columns. Are we together? Good. So we're having like 1, 2, 3, 4, 5 by 1, 2, 3. So we're having like 5 by 3 matrix. So by the time we transpose it, we are going to have a 3 by 5 matrix. So you are going to determine, or let's say you are going to select the range of that matrix whose the result. You are going to select the range of the resulting matrix. You are going to select the range of the resulting matrix. Now this matrix, as we defined earlier, is these are actually our rows, and then these are our columns, right? So we're having 5 here, 2, 3, 4, 5, and then we're having 3. So by the time we transpose it, we are now going to have something like 3 by 5, which is what we are going to have here. 1, 2, 3, 1, 2, 3, 4, 5. So the essence of defining this range is that when you now transpose it, the transpose will be imputed into this range. So if you don't define the range of the product or of the resulting matrix, you might not have all of them displayed. You might have maybe some part of it cut out, or you won't get the actual value, or maybe the actual transpose you need. So having done that, so let's try and do it again, which is 3 by 5, right? We have 1, 2, 3, 4, 5, and then we have 3. So we now say equal to, because you know that on Excel, before ever you type any formula, you would have to use the equal to. Then we now type in the function or the command, which is what? Transpose. You double click on it, transpose. We want to transpose this matrix, so we select everything, we highlight the range, and then upon doing that, to get the result, you use this Control Shift and Enter on your keyboard. Control Shift Enter. Are we together? Control Shift Enter, because if you just click on only Enter, you might not even have the actual result. So you use what? Control Shift Enter. Now the second thing now is that we want to multiply A transpose by A, right? Good. We know that this is A transpose. We've gotten A transpose. Now we want to multiply it by A. Now in matrix multiplication, there is a rule, I think compatibility or so, whereby the rows of one matrix must be equal to the column of the other before ever they can be multiplied, right? Good. So we're having a 3 by 5. Is it 3 by 5? We have 1, 2, 3, 4, 5. Then so we're having 5 by 3 and we're having 3 by 5. So we know that the row here is equal to the column here, and then the column here is equal to the row here, right? So by the time we multiply these two matrices, we are going to have a 3 by 3 matrix. So this actually was explained in the fundamental videos. The link to those videos will still be on the description section, where you will understand how we came about having the rows and column must be equal, and then knowing what the product will look like. So having understood that, we are now going to still define what the range where these other products will fit in. Remember that we defined this range, and you can see now the transpose has perfectly fitted into this range. Now we need a 3 by 3 array. So we are going to just define a 3 by 3 array, which is this. Good. Then the next thing we say what? Equal to. We are trying to multiply two matrices, so we are going to use this command, which is what? mmult, which is mmult. So you just type m twice, then you see it returns the matrix product of two arrays, an array with the same number of rows in array 1 and columns as array 2. That's why we say the row in one must be equal to the column in the other, right? Good. So you just double click on it. Then it's now asking you to select the first one. Now what's the first one? Remember the formula says what? A transpose A, which means A transpose will come first. So we select everything on A transpose. Then we now click on this comma. That will now enable us to select the next array, to select the next matrix. The array here is what? The matrix. Are we together? So when you click on that comma, it is now asking you to select what? The next matrix. And our next matrix, according to the formula, is what? A, right? So we now select everything on what? On A. So for us to get the result, the same instruction, Control Shift Enter. We now see what? The product of the multiplication is out, right? So this is the product you get when you multiply what? These two matrices, which is A transpose, which is this, multiplied by what? A. Are we together? Good. You can always pause, you rewind, and then you'll definitely get the solution to the problem. Now the next thing is what? We want to get the inverse of this product. Remember that the formula still went ahead to say A transpose A inverse, right? So we want to get the inverse of this particular product we have got now. So for us to get the inverse, we are still going to define the array, which is what? A 3 by 3 matrix. Then we still use what? Equal to. Now it's what? We have M inverse, right? Which is what? Inverse of a matrix. M inverse, inverse of a matrix. Then we are now going to select this array, right? Which is the 3 by 3 matrix. Then Shift Control Enter. It has displayed what? The inverse of this product. Here it is a product because it's ATA, right? A transpose A. So maybe even if it's not a product, if you have a matrix and you want to get the inverse, the instruction or the formula or the command you are going to use is what? M inverse, right? So that's how you get, or that's how we came about this A transpose A. Now the next thing we are going to check is what? A transpose L. We already know our L matrix to be here, and we already know our what? A transpose matrix to be here. So for us to have our A transpose L, remember the row in one must be equal to the column in the other. So by the time you go through those other rudimentary videos, you'll be able to get the concept behind it. Now we are having what? 1, 2, 3 rows and 1 column. So we're having what? A 3 by 1 product, right? So we define that array 3 by 1 equal to mmult, since we are trying to multiply two matrices. Then you click on it. Now what are we starting with? A transpose. which is this, right? So you select everything you have here, you click on comma, then the next is what? L, A transpose L, that's the product, right? So you now select everything you have here, so Control Shift what? Enter. It has given us what? The product we need, which is what? Multiplying A transpose by L, right? Now the final part of this is actually what? The product of this and this, which is A transpose A inverse multiplied by what? A transpose L, which is this particular value we are, okay, this matrix we are having here multiplied by what? This matrix we are having here. Because remember that this matrix is actually the what? The inverse, which is this part of the formula, and then this matrix we are having here is actually the product, which is also what? This other second part of the formula. So what we are going to do is what? This D, we are now going to multiply these two matrices, which is this multiplied by what? This multiplied by this, and it's the same procedure we have been going. How do we do that? Still using what? That same function of what, or that same command, or still using the same formula, mmult. Now the product will be what? A 3 by 1 matrix. So we define the array, then equal to, so since there is a negative sign here, we start by imputing the negative sign, then we say what? mmult, right, which is this matrix multiplication. Then we have what? A transpose A inverse, which is this A transpose A inverse, and then this is actually the product here. So we select everything, comma, what? A transpose L, which is this, right? Then we also select everything, then Control Shift Enter, right? Good. So we now have the product. We now have the product of these two matrices. The essence of having this negative sign here was to what? Affect the negative sign we had here earlier. Are we together? So if there was no negative sign here, there wouldn't have been a negative sign in the formula. Are we together? And again, you have to be a bit careful to introduce the negative sign before you start the mmult, else you might not be able to edit any of the array, because we encountered that while we try to do it the other way around. So you impute the negative sign before you start the mmult, like before you start the multiplication. Now we are done with this particular formula. The next thing is now we come to this V, right? To get this V, it's actually what? AD plus L. And then we know what our A is, which is the A matrix, and we just got our D, right? Good. So we can now multiply these two matrices. So how do we multiply these two matrices? Hope you've not forgotten the mmult, right? Now the dimension of the product is actually 1, 2, 3, 4, 5, which is the what? A 5 by 1 matrix. And you should be able to know how we came about this 5 by 1. So we have equal to what? mmult, right? Good. Then we are multiplying A by D. So this is A. We select everything we have here, comma, then the D, which is what we just got not too long ago, right? Good. Then Control Shift what? Enter. We now have the product of what? Of those two matrices, right? Good. Now the next thing we are going to do from here is that since we now have AD, our L is already known here, right? Which is this. Our L is known here. Therefore, we are now going to add the whole of this matrix, the product we have here, plus what? Plus our L. And addition of matrices most times are a bit, they are a bit simpler. Now that can go by just copying everything we have here, which is like Control C, right? Good. Then we try to paste it somewhere here. Let's just paste the numbers, right? Good. Then we just bring in another Excel formula by saying this cell plus what? This cell, right? Enter. Then we just drag it down, right? Good. So we just drag it down, and then we just get the sum of AD plus L. It's very simple, because addition of matrices must just correspond as the dimensions must be equal. 2 by 2, 2 by 2, 3 by 3, 3 by 3, 4 by 4. So it's actually 1, 2, 3, 4, 5, which is 5 by 1. So each of the elements we just add, and then we have something like this, which is the same thing as what we have here, right? Good. Now the final part of the video is when we are now going to add this our V. The V the other day on the last video, was what we used to what now apply correction to what the observed distances or the observed lengths, right? So we are now going to use this V to apply the corrections to the observed lengths. Now, what were the observed lengths? These were the observed lengths, right? So we can easily copy them from here, Control C, and then since these are the corrections we have, right? So we just paste them alongside, which is this, right? Good. So the next part of the formula is just adding them, which is what you can see here, adding them directly. So by the time you just come down here again, equal to this plus this cell plus this other cell, enter, then you just drag it down. So these values you can see here are actually the adjusted, or what was the term used? Yeah, these are the adjusted values of this length, right? These are the adjusted values of this length. However, what we need is the adjusted value of AD, and AD is actually AB plus BC plus what? Plus CD. Remember on the last video, it was divided into 3 segments, AB, BC, and what? And CD. So what we are going to do now is that this is AB, this is BC, and then this is what? CD. So we are now just going to what? Add these 3 together. So still the same method of addition, equal to, let's say, the sum, right? Good. The sum of these first 3 cells, enter. Now we have 150.075. So this is actually the adjusted length of what? Line AD, as we got on our last video. We hope we are not too fast, and if it was maybe fast to some extent, you can always pause, rewind, and then maybe catch your breath. Excel is for everybody. You can just practice it yourself, and that's the best part of it. You can practice it yourself, and then you would arrive at this same result we have gotten on the video. So yeah, thanks for coming to class. If you have any issue related to this, maybe an assignment, quiz, or anything you would want us to help you fix, you can always contact us, and we will be very glad or willing to assist you on it. So once again, thanks for coming to class today. We hope we've provided solution to this particular surveying problem. We are going to see you on our next video. Until then, try to have minimal errors in your observation, and have a nice time. Bye.